In this video, we will discuss how to find the location of images with scene lenses. And the first method is to do this using formulas. We have already discussed how to find the focal length of a scene lens using the lens maker equation in the previous video. And the position of the object S and the position of the image S prime are related to the focal length by the relationship that 1 over S plus 1 over S prime is equal to 1 over S. And also we have the lateral magnification that is given by minus S prime over S. And so again, the principal difficulty in using these formulas is with the sign rules for S and S prime. So I recommend one more time that you check the video on sign rules if you still have difficulties with the signs. In this video, we will discuss another method, which is called the graphical method, which you can use to find the location of images with scene lenses. So this method consists of drawing a few principal rays to identify the location of the image. The first principal ray that we will discuss are rays that go through the first focal point F1. So a ray through or proceeding towards F1 emerges parallel to the axis. And so you can draw any ray that goes through the point F1, and after going through the lens, that ray should emerge parallel to the axis. But in fact, you don't need to draw many rays, right? In fact, you only need to draw just one. That will be interesting for you, and this is a ray that will also pass through the object. And so, for example, if you have a convergent lens and an object is placed on the left side of the focal point, you will choose a principal ray that goes through the top of the object and through the focal point F1, and that ray will emerge parallel to the axis. Now, the second principal ray that we will discuss is a ray that is parallel to the axis, emerge in a direction that passes or appears to come from the second focal point F2. So in our example of a convergent lens, we can trace a ray that goes through the top of the object again, parallel to the axis, and that ray will emerge through the second focal point F2. Now you see that with these two rays, we can already find the location of the image because they cross at some point. And so you can say that this image is a real image and that it is inverted because the direction of the arrow is opposite to the object. And in fact, there is a third principal ray that you can draw to check that you did everything correct. And using these rules that a ray going through the center is not deviated and emerges at the same angle. And so we can plot this ray going through the top of the object and through the center of the lens, and this ray is not deviated. And so all the rays converge to the image location, but you can only just draw just a few of such rays to find the location of the image. Now, for a diverging lens, the rules for principal rays are exactly the same, but keep in mind that the focal length of a divergent lens is negative. And so what this means is that the first focal point is on the outgoing side of the lens, and the second focal point is now on the incoming side of the lens. So those are reversed compared to the case of a convergent lens. But in this case, you still have that ray parallel to the axis emerges in a direction that passes or appears to come from F2. A ray through or proceeding towards F1 emerges parallel to the axis, and a ray through the center is not deviated and emerges at the same angle.